Our second part is buoyancy. So we are going to use these two materials, brass and aluminum, to verify Archimedes' law. So actually this is a very classical traditional experiment. So we don't need the modern technology of the digital sensor. So we move it away a little bit. What we need is a caliper and these two spring scales. So of course water, we need enough water. And what we need is to measure the buoyant force as a function of the volume inside of the water. So the point is, we know if you measure the gravitational force or the feeling of heaviness of something is heavy, right? You can see the reading is about 125 Newton. So the unit is Newton or grams. Actually, I don't know what's the unit, but since it's always proportional to each other, so just use Newton. If you put them into the water, what you observe is the force goes down, right? Something helps you to lift this object. So this force difference is called the buoyant force. So if you want to measure the buoyant force on the atom, you measure the force hanging open in the air and measure the second force, which is inside the water. The difference is the buoyant force. So also you should keep an eye on the volume which is merged into the water. So there are equal distance lines which helps you measure the volume. So you can see which line is at the surface of the water. Each time you move it a little bit, so you have different volume. And we can use this caliper to measure, and to use that, well, you can measure like this for the length, and the cross-sectional area is given by the multiplication relation. So if you know A and B, you multiply them, you also know the cross-sectional area. So for example, what I measure is reading is given by these two rulers result. So the first one is 2 point. So this is not a typical reading, right? I'm going to remove it a little bit so you can learn how to read that. So now you can see it's 2.1 centimeter in the up ruler level. But there's another smaller ruler which you should see at which point these two lines, upper line and lower line, they coincide with each other. So it's about, well, in this case, I adjust it a little bit. So you can see this is about 1.5. So the total reading is the upper line 2.115 centimeter. That gives you the reading, but actually you don't need that much accuracy. So the volume, you know the volume into the water, and you know the buoyant force, you know how to verify Archimedes' law. So the point of Archimedes' law is why we have two masses, two different materials, is to convince you the buoyant force actually does not depend on how heavy the atom itself. It only depends on how much depth or how much volume it is merged into the water. In this case, the buoyant force is equal, right? Because they have the same volume into the water. Although this aluminum, it still feels lighter because it itself is much lighter, but the buoyant force does not depend on their molecule, their internal structure, only depends on the volume. That's the second part.